Objective 6, draw Lewis structures. So before we draw the Lewis structures, just a review of the basic process. Add up all electrons. That's valence electrons, of course. Draw your center atom. And attach all other atoms to it with a single bond. Fill in your lone pair. And then count up atoms used, or count up electrons used. And then you decide if any multiple bonds are needed. So let me work a couple examples of this. I've got 3 of them here that I'm going to look at. So carbon monoxide, it's a commonly used one because, as you may or may not remember, it forms something we call a dative bond. But when I look at what I have for electrons here, I have 4 from the carbon and 6 from the oxygen for a total of 10. So if I draw this, there really is no center atom. I just attach it with a single bond, fill in my lone pair, count up. I've used 2, 4, 6, 8, 10, 12, 14. And when I subtract, that means I've used 4 too many. So if I divide by 2, I realize I need 2 more bonds formed here. And there's only one place those 2 bonds can go, and that's in the center. That means each atom will still need a lone pair. And now when I count up, I've used 10 electrons. So this must be the correct Lewis structure. With HClO, I've got 1 plus 7 plus 6 electrons for a total of 14. And when I draw this, it looks like chlorine's the center atom, but ClO minus is actually an ion. So when I draw it, it's actually oxygen that's in the middle. But if you draw it with chlorine in the middle, it's really not going to make any difference. It's just going to change the electronegativity between hydrogen and the middle bond. But I go ahead and draw each one with a single bond. Oxygen still needs 2. Chlorine still needs 3, lone pair. And when I count up, I've got 2, 4, 6, 8, 10, 12, 14. So that is my correct structure. I had 14, I used 14, and they're all stable. With SO3, I've got the 6 from sulfur and then 6 from each oxygen for 24. And when I draw this with sulfur in the middle and attach each oxygen, when I count up, I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I've used 26. So that lets me know I need 1 multiple bond. And it doesn't really matter which oxygen I add the multiple bond to, because as we'll talk about shortly, it's actually going to resonate or move about. That's a double bond there. I'm not quite aligned here, but I mean a lone pair here. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that apparently is my correct structure for the SO3.